Now we're going to look at development tools for a software program. In the last lesson, we took our time to intimate ourselves on the essence and usefulness of computer software. We saw the relationship between computer software and the general term people refer to as computer program. By now we know that a software is an aspect of the computer that is intangible, but necessary for the execution of some works on the computer. We also know that a program is a sort of software. Software, however, could be grouped into several aspects. We have the system software and the application software. It is under these groups that we have the Android apps and the website development groups. All these software, however, would be useless if we didn't even know how to generate, create, and even modify them to meet our various specifications. In this section of the lesson, we're going to talk a little about how we can create software and modify them to fit our various requirements at every stage and sphere of life. At the end of this section, we should have the general idea as to touching the creation of a software for the general purpose. In order to create a software and even modify it to the use of humans, one must have the knowledge and understanding of language the computer speaks. These languages are referred to as computer programming languages. Unlike the human languages that are generally purposed, each computer programming language has a specific target and use. The programs all fit together to achieve a wide goal, with each program as the building block. Each software created is going to be needing 2 or more programming languages for its creation. Someone can create a software with the aid of just 2 programs. Someone else can create with the aid of several programs. It all depends on the kind of program to be created and the specification of the software. Among these programming languages are Fortran, COBOL, Python, LSP, Haskell, C++, and so on. As simple as it seems, computer programs aren't that easy to compute, but with the aid of software like compilers that translate these programming languages to machine language, that language can then be understood by the computer because they have been simplified. Consider the following program fragment written in the Python programming language. Subtotal equals 25, tax equals 3. Total equals subtotal plus tax. These 3 lines don't make up a complete Python program. They're just a piece of the program. The statements in this program fragment look similar to expressions in algebra. We see no sequence of binary digits. 3 words, subtotal, tax, and total, called variables, are used to hold information. Mathematicians have used variables for hundreds of years, even before the first digital computers were built. In programming, a variable represents a value stored in the computer's memory. Familiar operators, such as equals and plus, are used instead of some cryptic binary digit sequence that instructs the processor to perform the operation. Since this program is expressed in the Python language, not machine language, it can't be executed directly on any processor. A program called an interpreter translates the Python code into machine code when a user runs the program. Apart from these programming languages, another necessary tool for development of software is an editor. This is a component that allows the programmer to enter the program's source code and save it to a file. Some editors make it even more interesting by using colors to highlight the language features. The syntax of a language refers to the way pieces of the language are arranged to make well-formed sentences. To illustrate, the sentence, "The tall boy runs quickly to the door," uses proper English syntax. By comparison, the sentence, "Boy the tall runs door to quickly the," is not correct syntactically. It uses the same words as the original sentence, but their arrangement does not follow the rules of English. Similarly, programming languages have strict syntax rules that must be followed to create well-formed programs. Only well-formed programs are acceptable and can be compiled and executed. Some syntax-aware editors can use colors or other special annotations to alert programmers of syntax errors before the program is compiled. Another needed feature for creating software is a compiler. Now, we had learned earlier that these compilers are translators of other languages on the computer to the machine language. The code to be translated is referred to as the source code, while the code to be translated into is referred to as the target code. Compilers can translate either from a source code to the machine language or from a source code to another language. For example, the target code could be another source language. The earliest C++ compiler translated C++ into C, another higher-level language. The resulting C code was then processed by a C compiler to produce an executable program. C++ compilers today translate C++ directly into machine language. So to create a software, you also need to have an interpreter. Now, interpreters are also like compilers. They translate source code to machine language. This interpreter, however, works a little differently from the compiler. The difference is that an interpreter translates the source code as the program runs, while a compiler produces an executable program. To execute a compiled program, it does not need to be compiled again, while to run a translated program, it needs to be retranslated. In the long run, a compiled program runs a lot faster than a translated program. Python, for example, is used as an interpreted language, but there are compilers available for it. Debuggers are also essential because they allow a programmer to run a program and simultaneously know what source code is being executed. Debuggers are more than necessary for the location of errors. They are used for the repair of programs that contain errors. Profilers are also necessary for the creation of a software or a program. A profiler is used to evaluate a program's performance. It indicates how many times a portion of a program is executed during a particular run, and also how long that portion takes to execute. Profilers also can be used for testing purposes to ensure that all the codes in a program are actually being used somewhere during testing. This is known as coverage. It is common for software to fail after its release because users exercise some part of the program that was not executed any time during testing. The main purpose of profiling is to find the parts of a program that can be improved to make the program run faster. Many developers use integrated development environments, or IDEs. An IDE includes editors, debuggers, and other programming aids in one comprehensive program. Examples of commercial IDEs include Microsoft's Visual Studio 2010, the Eclipse Foundation's Eclipse IDE, and Apple's Xcode. Idle is a very simple IDE for Python. Despite the plethora of tools and tool vendors' claims, the programming process is all but trivial and not automatic. Good tools are valuable and certainly increase the productivity of developers, but they cannot write software. There are no substitutes for sound, logical thinking, creativity, common sense, and of course, programming experience.